One of the fundamental things which we are made to learn from childhood is our address, the location of our place in the locality, in the city, in the state, or in the country. But what if an alien comes one day and asks you about your address? What would you tell? We should also learn our address with respect to the universe in an interstellar scale. This video is thus based upon our address, that is the location of Earth in the universe. In short, I'm going to tell about the address of our Earth. The Earth is located in the solar system. Solar system is in turn located in the solar interstellar neighborhood, which is located in the Milky Way Galaxy, which is in turn located in the local galactic group, which is further located in the Virgo Supercluster, which forms the Observable Universe, and it has a bigger universe than which we can't see because light can't reach us from those parts. Actually, it can reach us, but it has not yet reached us. So let's begin in detail. We will begin from Earth, that is our home. Earth is a rocky planet, third planet from the Sun in our solar system. Is the most planet which can bear life. Its diameter is about 12,700 kilometers. If we move away from Earth, we will see the geospace. Now, what is the geospace? Geospace is the shape of the magnetic field of the Earth. The side of the Earth which faces the Sun, in that part, the magnetic field is squeezed by the incoming solar wind, and the part of the Earth which faces the opposite direction from the Sun, the magnetic field of Earth in that part is elongated. It is again due to the incoming local solar wind. So, the magnetic field which faces the Sun is called the sunward side. It is 63,000 kilometers in length, and this side which faces away from the Sun is 63 lakh kilometers. That is the trailing side. This is the space dominated by Earth's magnetic field. Next, we come to the orbit of the Moon. The diameter of the orbit of the Moon is about 7,70,000 kilometers across. The average diameter of the orbit of the Moon relative to the Earth. Next, we come to the Earth's orbit around the Sun, which is 300 million kilometers across. That is 2 astronomical units. Now, what is an astronomical unit? It's a unit of length. An astronomical unit is the average distance of the Earth from the Sun. So, the orbit of the Earth would be twice, that is the diameter of the orbit of the Earth would be twice the radius, that is 2 astronomical units, which is, I said, 300 million kilometers across. Now, as Earth is the third planet from the Sun, its orbit contains the first 2 planets, that is Mercury and Venus. Next, we come to the inner solar system. Inner solar system comprises of the first 4 planets from the Sun, that is the Mercury, Venus, Earth, and Mars, which are the rocky terrestrial planets. The radius of Mars is about 6 astronomical units across. Not the radius, I'm sorry, the diameter is 6 astronomical units across. And the inner solar system also comprises of the asteroid belt, which is a stream of asteroids, rocks, between the orbit of Mars and Jupiter. The outer solar system, the orbit of outer solar system is, the diameter is 60 astronomical units across. It surrounds the inner solar system and comprises the outer planets, that is Jupiter, Saturn, Uranus, and Neptune. Next comes the Kuiper Belt. Its diameter is 96 astronomical units. It comprises of a belt of icy objects surrounding the outer solar system. It also contains dwarf planets like Pluto, Haumea and Makemake. Next comes the Heliosphere, whose diameter is 160 astronomical unit. The maximum extent of solar wind and interplanetary medium. Next is the scattered disk, whose diameter is 200 astronomical unit. It is a region of sparsely scattered icy objects surrounding the Kuiper Belt. It contains dwarf planet Eris. Next comes our most famous Oort cloud, which is 1 lakh to 2 lakh astronomical units across. That is 2 to 4 light years in diameter. It is a spherical shell. The shape of the Oort cloud is a sphere. It's a spherical shell of over 1 trillion comets and icy bodies. Now comes our whole solar system as we see from the outer edge. It is 4 light years across. It is our home planetary system. At this point, the sun's gravity gives way to that of the surrounding stars and interstellar medium. After the solar system, we can see the local interstellar cloud. It is 30 light years across, interstellar cloud of gas and dust through which the sun and a number of other stars are currently traveling. It contains local group of stars such as our own sun, such as the star Sirius, nearest star Proxima Centauri, and Vega and other stars, etc. etc. Next is the local bubble, which is 210 to 815 light years across. It is a cavity or void. It is not actually a bubble, that is actually a cavity or void in the interstellar medium in which our sun is traveling along with its neighbor stars, which I had just told. It was created by a past supernova, an interstellar explosion caused by the death of a star, which moves all the particles and objects away from each other, so a void is created, which is the local bubble in which our sun is passing at the current moment. Next comes the Gound Belt, which is 3000 light years across. It's a ring of young stars through which our sun is currently traveling. Now we come to the galactic scale, which is the Orion arm. Our sun is present at the Orion arm. It's 10,000 light years in length. It is a spiral arm of the Milky Way Galaxy and is a subpart of the Sagittarius arm. Our sun, as I told, is present in the Orion arm of our Milky Way Galaxy. If you see the picture of the Milky Way Galaxy and in any other galaxies, spiral galaxies, you will see a number of spikes, a number of curls coming from the center of the galaxy extending outwards. These are called the arms. One of the arm in our Milky Way Galaxy is the Sagittarius arm, whose subpart is the Orion arm. Our sun is present in the Orion arm. Next is the orbit of the solar system. As the name suggests, the orbit of the solar system is the orbit of the sun around the galactic center. Now, how it is created? The center of the Milky Way Galaxy contains a supermassive black hole called Sagittarius star A. Our sun and all other stars are bound by that gravity, and as Earth moves around the sun due to the gravitational influence of the sun and the Earth, similarly the sun moves around that supermassive black hole due to the mutual gravitation influence between the sun and that supermassive black hole. The diameter of that orbit is 56,000 light years. Now the Milky Way Galaxy, it's 1 lakh light years across. It's our home galaxy. It contains 200 to 400 billion stars and is filled with interstellar medium. Now after the Milky Way Galaxy, here comes the Milky Way Subgroup. It is 2.74 million light years in diameter, or 0.84 megaparsecs. It is a group comprising the Milky Way Galaxy and its small satellite galaxies such as the large and the small Magellanic Clouds, the Ursa Minor dwarf, the Sagittarius dwarf, etc. Next comes the local group. It's 3 megaparsec across, group of at least 47 galaxies. It is dominated by the Andromeda Galaxy, which is the largest, the Milky Way Galaxies and the Triangulum. The remainder are small dwarf galaxies. Now comes the Virgo Superclusters. It's 33 megaparsecs across. It is a supercluster of which our local group is a part, and it is made up of roughly 100 other local groups like our own. Next is the ISISCJ Supercluster complex. It is 300 megaparsec across. The galaxy filament. It is the galaxy filament of which the Virgo Supercluster is a part. Now, as we see the structure of the universe, we can see it is comprised of thousands and millions of intermingled filaments. Those filaments are made by such Virgo superclusters and other such superclusters. This ISISCJ supercluster complex is one such filament to which the Virgo supercluster is a part. Next is the Observable Universe, which is 28,000 megaparsecs in length. The scale structure of universe consists of more than 100 billion galaxies arranged in millions of superclusters, galactic filaments and voids, creating a foam-like structure. After the observable universe, we can say that the whole universe is much bigger than the observable universe, and it is true, as we can't see the whole universe because light coming from beyond the observable universe has not yet reached us because the speed of light is finite. So the universe is very big, which we can't imagine. Now, after the universe, many science fiction stories and many theories say that there are other universes which make a group called the multiverse. We are not alone. This universe is not alone. It makes a group called the multiverse. But our science progresses. We cannot get any evidence of any other universe because nothing can come from other universe in our universe as an evidence. So we can think about the multiverse theory as only a fictitious hypothesis. This is the picture of our whole universe. And now we can see how small is our own Milky Way, how small is in turn is the Sun, the Earth, and we.